In this video, I want to wrap up our forecasting section. For the last 3 weeks, we've been talking about many different aspects and methods for doing forecasting. A couple things I want you to take away. The first is that everything we've been focused on has really only been a piece of the whole demand process. And so we've been focused on forecasting, and this is not a means in the end to itself. It is meant there to feed into other pieces of the system. So it's part of the larger demand planning and demand management processes. It also feeds into the inventory replenishment system. So when you come up with forecasting, and you need to be thinking about who's going to use the forecast. How does this guess fit in? So we covered many different methods and approaches. We covered subjective approaches, such as judgmental, where someone somewhere knows, and I might use something like a Delphi approach or a panel of experts to help me come up with a forecast. You might have experimental approaches where you do some kind of local test, whether it's a customer survey or a focus group, and then you extrapolate those results to the larger market. And we spent a lot of time on objective approaches. And the big one we spent most of our time here is in time series because it's so widely used. And so we covered a bunch of different methods, but they all focus in on the idea of pattern matching. The first ones we looked at were simple models, and these only looked at the level pattern, that we have a stable or stationary demand, and we looked at moving average, cumulative forecast, naive forecasts. We even introduced simple exponential smoothing, which only assumes a level pattern. But then we also extended that to look at trends, when we think there's an underlying trend in the data, as well as seasonality. And so the idea is, when we introduced exponential smoothing, as opposed to some of these simple models, is that we made the decision that older information is not as valuable as newer information. The value degrades over time. And so the idea is exponential smoothing balances how much I value new information and old information. And the smoothing constant you use, whether it's the alpha for the level, the beta for the trend, or the gamma for the seasonality, that is what determines how nervous or calm and how responsive or relaxed my forecast is going to be. And you probably also took away that it takes a lot of bookkeeping, a lot of updating, and there's a lot of tricky initialization. Luckily, there's some great software out there, but it's important that you understand what the software is doing. Then we looked at causal analysis, and this is where we think there's an underlying driver that we can capture, and we can then determine what the demand's going to be if I can capture that underlying driver. And we introduced the idea of ordinary least squares regression, showed in great detail how to use that in spreadsheets. And the idea here is that I have a single dependent variable, y, demand in our case, and that there's one or more independent variables, x1, x2, and we try to find the correlation of those independent variables to that dependent variable, demand. We showed how to test the model using R squared to see the overall fit, and we talked about how you test the individual coefficients to make sure you're explaining things correctly. Some watch outs. Remember, if you come up with a correlation, that's all that we're finding here. This R squared is just a correlation coefficient. That does not mean you found a causation. You just found that the numbers tend to move in the same direction. Also, you should make sure you avoid overfitting of the model. It's a common early mistake for people to try to really drive their forecast to have a very high level of fit on the historical data. That doesn't necessarily mean it's a good forecast going forward. Again, think of what the forecast is going to be used, who's going to use it, and how is it going to be used. So you want to make sure that it's useful for their purposes. And also, we went over all these techniques, but in practice, most firms use all of them. They use a portfolio, and you will probably use some of all of these techniques in your career going forward. So what did we do in this lecture? Well, we covered two special cases. The first was with new products, and this is where there is no history. And so therefore you need new methods. And we introduced two methods that are very related. The first is a looks like forecasting, where it's pretty simple. It is what it sounds like. I look for similar products that have launched and I see how well my product is doing compared to ones that look like that. This is very commonly used. Then we introduced the Bass diffusion model, and this is where you have two effects, the innovator or early adopter effect and the slower or imitator effect, which is more dictated by word of mouth. And so these two effects are combined, and you can use these two effects to try to estimate what the pattern of adoption looks like for your product or your new technology. We also talked about different types of new products because different methods are used. So we talked about these new to world and new to company products that have never been seen. And we can think that we're going to probably use some of the more subjective measures here because we don't have any history. And so you're going to need panels of experts, and you're going to use Delphi approach and these forecasts where you don't have any data. At the other extreme, down here, for product repositionings and cost reductions, I'm probably going to have some data because I've got my products already out there, so I have some history, I have some data, so I can probably use some of these more objective time series and causal analysis. And for these middle ones, this is where I have a product that I'm extending or improving, and so the idea here, I'm probably going to use a lot of those look-like techniques that we just talked about, because those are kind of in the middle ground. But in any case, you're probably going to use a combination of all of these for each of these. But generally, that's how it's going to typically falls out. Then we also talked about the new product development process, which is critical for any company because so much revenue comes through new products. And we introduced the idea of stages and gates. And it's very important in your company you understand how your new products are introduced because you want to make sure that the supply chain perspective is brought in as early as possible to the earliest possible stage that you can. Finally, we looked at intermittent demand. This is the case where you have sporadic demand that doesn't happen regularly. And so you think of spare parts for things like that. And then Croston's method is a way of smoothing that out. And by smoothing that out, you're back to using exponential smoothing again. It's a nice way to make an easier forecast, a better forecast to feed into your replenishment systems. Okay, last comments about forecasting, and then we'll dive into inventory in the next lecture. First point, data issues dominate. Three key things here. You need to make sure you recall and remember that sales data is not demand data. They're close, but when you're all stocked out of something, you're not going to record any more sales, but you might have some demand. So you might miss some demand. So your sales is actually a conservative estimate of your demand. Transactions can aggregate and skew the actual demand. Think of if I have an order policy where you have to order a minimum truckload is the minimum order. That's going to bunch things together, aggregate them, and it's going to show as big spikes, similar to what we saw in the Croston's method with sporadic and intermittent demand. What you want to really look at is trying to understand what the underlying demand is, not necessarily the ordering pattern. And we'll talk much more about this when we get into inventory. Also, historical data might not exist. In all of our examples, we assume we have data because we can do that. But in practice, it's hard to get some of this historical data. Most companies do not keep a lot of their old forecasts because of the storage of information. It can still be expensive if you're storing a lot of items, a lot of information. So it's one of the biggest challenges you have will probably be finding that historical data. Some practical things you can look for. Make sure when you do your forecasting that you're, again, forecasting as a pure and unbiased forecast. There's an old saying in supply chain management that no one gets fired for having too much inventory. You might not get your bonus, but you won't get fired. You'll get fired if you stock out. And so knowing this, a lot of people will take their forecast and they'll bias it, they'll pad it, they'll add more in because I don't want to run out. The problem with that is that snowballs. The next person might see that forecast and do the same thing. And pretty soon you've got this huge bias that goes in as a forecast when actually it's very padded. And this happens quite frequently. So the critical thing to look for when you're forecasting, a forecast should be a pure forecast. It shouldn't be based on what you want it to be or what you think the inventory should be. It's based on the forecast. So we spent a lot of time dealing with statistical validity, and the whole idea here is that yes, you want to make it statistically valid, but you also want to make it useful. And so going to the highest R squared and overfitting the model is something you always have to be conscious of to make sure you want to come up with a useful forecast rather than something that's ridiculously overfitted. Demand is not always exogenous. You can influence it. This is part of the demand planning process. You don't need to necessarily take demand as always a given. You can influence it, and your different parts of your company are probably influencing a lot of the demand that you're trying to forecast. Another thing to look for is any kind of error creeping. So typically Let me go back just a little. Another thing to look for is error trending over time. Is your error term creeping? Parameters tend to not be updated once a system is put in. So it's very good to take a look at this and make sure everyone knows that you understand what alpha, what beta, what are your parameters that you're using. Have they been updated? Have they been changed since the system was implemented? These are kind of things that you should take account of. And my final point is there are hidden costs of complexity for forecasting as well as other processes. And generally, the more complex, the more complicated a system is, one, the less frequently the parameters are checked and updated. Two, the less likely anyone who uses the system actually understands how it works. And finally, the more complex the system is, the less likely the operational teams will trust the output. So you have to really balance the idea of an accurate system with something that's transparent, because the black boxes tend to be hard to convince the people who have to use it to actually use it. Okay, so that concludes our discussion on forecasting. And so hopefully if you have any questions, comments, or suggestions, you use the discussion.